All right, so I'm hoping I can make this a little faster than some of my latest videos. The new binary bin, I just want to show you how it goes together because I didn't want to, write out the documentation. It's a bit of a pain. And I also just realized standing here, I'll fix it, that I didn't post about a non-AMS version. You can definitely make this without an AMS. You just won't get the inlaid text, obviously. But you can remove the inlay, which I'll do, and post an STL, and then just use a marker and pen in the numbering and the lock symbols and stuff. And then on the inside, there's a similar piece that will do the same. But basically, you've probably already seen it, but it's a binary lock, a mechanical binary lock grouped into nibbles. So my idea was that you save your code, your key to this in hex, and then gives you a chance to exercise your conversion of hex to binary. And I hadn't done that for years, and so it was kind of fun for me to get back to it. And I tried to show my wife, and she's like, she couldn't cope with the fact that there's another numbering system besides decimal. So it was really fun for me to go down that path. Anyways, I think also it's kind of cool. I'll probably use this again. I designed this pop-up. It's a print-in-place one-piece pop-up handle that lies flat, and I think that came out super well, so that's fun. And you want to put a drop of lubricant down in the bottom of the sphere, the half sphere, which is where it kind of comes down and locks into the vertical. Anyways, I'm kind of getting ahead of myself. Bumpers just peel off. And then I'll take this apart and show you how it goes together. So it can be used without the TPU bumpers. They were just there to try and be a little bit fancier. So I'm going to take this apart, and then I'll turn the video back on and show you how it goes back together. All right, so these are all the parts that make up the binary bin. These binary keys that set the lock. There's two versions. Probably hard to see here, but one's got a gap kind of 3 millimeters from the end, and the other's got a gap about 6 millimeters from the end. So this is a 0 and this is a 1. And what I did was I marked all the ones with just a black marker. So when I'm building it, it's a little easier to see. And of course, mark it on the underside so that it's not visible from the outside. I could have made an AMS version of this, but it's a pretty small part, and I didn't want to waste the time. And so I think this works out quite well. And so maybe we just start with the keys, because this is the most important thing, is that you set your combination, print as many of each of the ones and zeros as you need, or a couple of spares even. So that means decide what combination you want, or else print a lot of both, and then decide your combination. And for the purpose of this, I'm just going to make it 010101 repeating. You can see the numbers are marked on here, and if you do this with a non-AMS, print it in a light material, and then you can use a felt marker to mark the numbers on it. So you're going to start with whatever number you're starting with. In my case, it's a 0. I'm going to put that between the 00 and the 01 position is the 00. Right at that point, there's a notch, and that's an indexing mark for when we assemble this, and it corresponds to an arrowhead on the back side to help find it. And so basically, I don't need to waste too much time for you guys on this, but just build this. So I'm going to go 010101 repeating, and I'll come back once that's all put together. All right, so those are all in, some of them backwards. Oh my goodness. Let's do that again. Okay, that was actually a pretty good demonstration of what not to do. I had a bunch of them in backwards and upside down, and so just trying to go too fast and thinking about my next project already. So the important thing is when they go in, make sure they're in this orientation. The dip switch notch for controlling the switch should be on the side with the numbering, and you should feel the detent action as you put them in. And before you go any further, what you want to do now is look over and make sure that it's flat on this side. Everything's smooth. You've got all the bits in the right place, and then drop it into the lid. When you drop into the lid, that indexing mark that I mentioned earlier, which is right here, and also at the arrowhead, should align with this arrowhead. So those just go in, and you should feel it kind of snap in once it goes past the ridge on the inside of the lid. Now is the most important moment in the whole build process, and that is to make sure that as you go around the edge of the switch disc, which in my case is this black one, that every gap lines up with the edge of it. and that's your combination there. So you want to do two things. A, make sure that's all set correctly and that there is a gap all the way around, because you won't be able to build it unless that's basically your combination is set to the unlock state. So I've got mine like that. And I highly recommend now taking a photograph of this like this, so that once you get this together, if you have any issues, you can reverse backwards and figure out what your code is based on that index mark. Because if you build this and don't know your code, you're not getting it open. You're going to have to break it. So that's super key. So now we've done that. We can set that aside for a minute and build the orbital system. The orbital system, I haven't found any one way is better than the other. This can go in any position, so you can just drop it in, and it takes a bit of squeezing to get it past the threads there. Then the only thing about these going in is you need to make sure the gears, like the last few projects I've done, I think of it like an arrowhead, lines up with the other one. Otherwise, it won't sit down properly. And you can just flex it a little bit. They should pop in like that. You'll kind of hear it snap. Make sure as you go around, each one's facing the right way. Okay, all facing the right way. And a really good test once you get the 4 planet gears in off the sun is it should feel really smooth. If it's not moving smoothly here and everything's laying flush, then you've got one of them or more backwards. And that's super important because the next one's also a little tricky. The ring gear, it has to, the little protrusions, there's 4 of them on the inside, has to be offset from the planet gears, so it stays away from these gears. So there's a gap from here to here where it sits in. I've been turning it so it's at one extreme, which in my case right there is one of them, and then counting the gears teeth. If I think of that is the last one that's mostly almost fully engaged, then there's 2 teeth here. So you want to look and make sure as you go on each of them it's the same. See there, I've actually got only 1 tooth, so I need to bring that back around a little bit. And I'll do it another way, and that is to just force it on. And once it goes on, and I can see I've got 2 free teeth there, 1 free there, 2 free there, and 3 there. You would think that would go on perfect every time, but it doesn't. It actually takes a bit of effort to get it right. And when it's not right, which in my case, it's not right now, you can't spin it, or if you do, it's very, very stiff to turn. And when you've got it right, this will spin really easily. So once you've got it to where I am now, and you can see, okay, there's 2 that are matching, they got 2 free teeth. This one's close, this one's got 3. So I just need to lift up this side, which is helpful if you have something to pry it with. Pry it out, and just work it over. And that's as simple as that. And now, hopefully if I've got it right, no, it's still stiff. So it's not right. And when you get it right, you'll feel the detent at each end of its position. So when you turn it one way, there's a detent there, and the other way is a detent. But I'm still not happy with that. I can still see I'm off on this one. This is actually the most difficult time I've had putting this together yet. So it's usually falls into place a little easier. So let's just take it off, get it loosely aligned, and try again. There we go. That felt better. There you go. So now when they're all equally 90 degrees apart, same number of teeth free, you can see how easy it is to rotate it. It's super easy, and you can feel the detent at each end. Then you know you're in. And that's it, you're built. So this screws in. Rotate it down, you'll hear it snap. That's locked now in. And it's being locked by 4 kind of compliance springs here. And you can just stick a toothpick under each of them, all 4 of them, and back this out. But I found that a little precarious, so I just made this little tool. And as long as the 4 heads here line up with the 4 holes, just give it a little bit of pressure inward and rotate, and that undoes it. So you can get this back out really easily. But don't worry, you don't really need that. If you're going to set your code and leave it, if you have to open it once because you screwed up, just use something else, and then you save a print. But if you're going to do it over and over again, like I have, the tool is quite helpful, and just lock it back down again. And so that's it. It's built. And as long as I've got my code correct right now, see, I haven't adjusted it. This is movable. But if you change any switch, then it locks. So all of them have to be in the correct position or it won't open. And I did mention, probably in a really confusing way, that I made a non-binary lock state here. So each switch actually has 3 positions. And I kind of did that because if you set your code and you unlock this, okay, so you've set your code, you unlock it, you take this off. Anybody looking at this can see your code. So you would want to quickly shift them. And if I only had 1s and 0s, some of them would be correct, even though somebody looking at it wouldn't have any idea which were correct. So I just thought it'd be kind of fun to make them all that you can just put them all to a lock position, this sort of this non-binary state. And now there's no clue to anybody of what was moved and what wasn't moved because everything's been moved to a lock position. And then as long as you carefully put them back to their proper positions, you can open and close it again. And that's it. The lid can go on in any orientation. Doesn't really matter. And the bumpers are identical, so those can go on either way. And it's not really a puzzle, but kind of fun for those who are nerdy like me. I put actually a ASCII encoded, it's not really a message, but I put something ASCII encoded in the outside walls here. So if anybody wants to decode that, it's not difficult, but kind of fun. So it was fun for me anyways, making it. Might not be fun for anybody else, but anyways, that's it. Hopefully I can boil this down to a pretty short video and then carry on with something new. Thanks, everybody. Talk to you later.